Gotta say, how good is AI image generation? You just chuck it a few keywords for what you want an image of, and it goes away and makes an image. And the prompt I used for this one was something like silly donkey wearing a tinfoil hat. I didn't quite get the hat part right, but it's still pretty cool. Anyway, the reason I used that prompt is because we're looking at some observations made by Tinfoil Hatman. And he is indeed a fucking donkey. So as you can see, he's appeared on Flat Earth Debates 1987, 1990 and 1995, making some observations over the Bristol Channel in southwestern England. And just quietly, how badly is Nathan struggling for views? He's got like 25,000 subs, and if you have a look over the last few months, it looks like the only times he cracks 1,000 views is when he name drops a Glober in the title. Like the other day, he put TKOR in the description, which is the King of Random YouTube channel, which has 12 million subs, and he still only barely cracks 1,000 views. So come on, bro. You've got a wife and 2 kids at home to beat up, so go get a real job. Anyway, back to Tinfoil Hatman and his observations on the Bristol Channel. I'll save you the very long, boring and drawn-out presentations he's done on FED. But basically, he set up a telescope on the seabed of the Bristol Channel and just panned across to see what he could see. But the 2 main targets we're going to be looking at are Flat Home Lighthouse down on the bottom left and a little drain outlet over near Avonmouth. And the main thing we're going to concentrate on is his claimed observer height of 1 meter. So I hit him up in Discord to see if he would defend his observation. And the first question I asked him was, what was the time of the observation? Because the observation was done on the Bristol Channel, and the Bristol Channel has one of the largest tidal ranges in the world. And just to show this in like a visual kind of way, I've grabbed some images from a webcam on the Bristol Channel, just so you can see how much the water changes. So here we go. That's mean sea level, and that's high tide. And you can get an idea of the scale now with those fishermen. That's mean sea level again, and back to low tide. So it has a huge tidal range. Anyway, I got no response, so I sent him another DM asking for the time of the observation. I tagged him in the text channel, no response. Tagged him in the text chat again, no response. Until I got this absolute doozy of a message forwarded from Tinfoil Hatman via Brian's Logic, and just wow. Apparently I'm going to be sued because I told him his observer height is not 1 meter, and he somehow took that as an attack on his character. Well, I am going to attack your character now, Tinfoil. You're a fucking snowflake. And this kind of response was honestly embarrassing for a grown man. Anyway, he did say you'd better have evidence to back this up. And if you're a regular viewer of my channel, then you already know that of course I have evidence to back this up. So let's look at Tinfoil's observer height, shall we? Right, so Tinfoil gives his very precise observer coordinates up in the top right, down to 1/10 of an arcsecond. And if you go to those coordinates in Google Earth Pro, it gives you an elevation of 1 meter. And here's a photo from Tinfoil showing his telescope setup, which he says is 1 meter tall. So already we're at 2 meters above mean sea level. But let's have a look at the tides. So here are the tides for the Bristol Channel on the day of the observation. And you'll see the low tide just before 5 p.m. was at a height of 2.38 meters. Now, what a lot of people are not aware of is that this height is not a height above mean sea level. It's a height against what's called chart datum. And what is chart datum, I hear you say? So the 0 point for chart datum is what's called the lowest astronomical tide. And that's usually when the specific alignment of the sun and the moon cause the greatest tidal effect. And this website, called the National Tidal and Sea Level Facility, will tell you the difference between chart datum, which is the datum for the height of the tide, and ordnance datum, which is the British datum for the heights above mean sea level. And you'll see for Avonmouth, that difference is a whopping 6.5 meters. So if the tide was 2.38 meters above chart datum, and chart datum is 6.5 meters below mean sea level, then the level of the water at the time of the observation is 4 meters below mean sea level. So let's calculate Tinfoil's actual observer height. So we've got his telescope above the surface of 1 meter. The elevation of the surface above mean sea level is another meter. And mean sea level above the water is an extra 4 meters. So his final observer height, 6 meters above the water. And this is what led to the title of this video and why I sent this meme to the likes of Tinfoil Hatman, Brian's Logic, and Adam Meakin. Now, personally, I actually refuse to believe that these people are that stupid. Maybe Brian is, but Meakin supposedly has a bachelor's degree. So there's absolutely no chance that he doesn't understand it. He just doesn't have the intellectual integrity to call out his fellow flurfs. Anyway, if you're sticking 1 meter in as your observer height, then you're telling the curve calculator that you are 1 meter above the stuff that you are saying would be blocking your view on a globe, which is obviously the water. But as we've just shown, tinfoil is actually 6 meters above the level of the water. Now, obviously, as the tide goes out, some of the surface of the channel that's below mean sea level will be exposed. As to how that affects the observation, that's not my problem. I'll leave that up to tinfoil to analyze. Anyway, let's look at the two observations that tinfoil made, but with an honest observer height of 6 meters. So on the left here is tinfoil's photo of Flatholme Lighthouse, taken with his iPhone through the lens of the telescope, and that somehow explains the diagonal lines. Anyway, according to Wikipedia, the actual height of the building itself is 30 meters, and the focal height of the lamp in the lighthouse is 50 meters above mean high water. So let's put some markers for some known heights. So the height of the lighthouse itself was 30 meters, easy enough. And here's roughly where the lamp is. So if we scale the 50 meter focal height against that 30 meter height of the building, we can see that mean high water mark is way down here. So that already destroys the observation because high tide is already way below that horizon. But it gets worse because mean high water is actually 13.33 meters above chart datum. So we can work out where mean sea level is, and we can also work out the actual water level at the time of the observation. So yeah, that's quite a lot of bottom-up obstruction. And these Muppets think we're seeing right down to the base. Right, so the second landmark we're going to look at is this drain over near the SO Avonmouth terminal. And if you wave your mouse over the surface in Google Earth Pro, right where the water comes out, then it does indeed say that it is 0 meters above mean sea level. But remember, the water level at the time of the observation is 4 meters below that because tinfoil went there when it was low tide. So the viewer height we need to put in is 6 meters because he's 6 meters above the water. But when you look at the hidden amount, you have to remember that this figure is also relative to the actual level of the water. So a hidden height of 1.5 meters, when the water is 4 meters below mean sea level, means that you are actually seeing down to 2.5 meters below mean sea level. So yes, tinfoil, the drain, which has an elevation of 0 meters above mean sea level, should be seen easily. So that's the end. I think I'll leave it here by showing a couple of Skype messages that I sent to Tinfoil Hatman, which Skype says that he has read. So yeah, Tinfoil Hatman, you are lying about your observer height. Are you going to sue me, you fucking jackass?